Water and steam fittings and accessories. Boiler systems. A boiler operates using the feed-water system, the steam system, the fuel system, and the draft system. The feed-water system supplies water to the boiler. The steam system controls and directs the steam produced in the boiler. The fuel system supplies fuel and controls combustion to produce heat. The draft system regulates the movement of air for combustion and evacuates gases of combustion. Water and steam fittings and accessories are required to supply and control water and steam in the boiler. Boiler fittings, or trim, are components such as valves directly attached to the boiler. Accessories are pieces of equipment not necessarily attached to the boiler, but required for the operation of the boiler. All boiler fittings and accessories must be constructed in accordance with the ASME code. Safety valve. The safety valve is the most important fitting on the boiler. It will pop or open to release pressure when pressure inside the boiler exceeds the maximum allowable working pressure, or MAWP. Safety valves are installed at the highest part of the steam side of the boiler. No valves shall be installed between the boiler and the safety valve. Safety valve capacity is measured in the amount of steam that can be discharged per hour. The safety valve will remain open until sufficient steam is released and there is a specific amount of drop in pressure. This drop in pressure is the blowdown of the safety valve. Safety valve capacity and blowdown is listed on the data plate on the safety valve. Spring-loaded safety valves are the most common safety valve. A spring exerts pressure on the valve against the valve seat to keep the valve closed. When pressure inside the boiler exceeds the set popping pressure, the pressure forces the valve open to release the pressure. The ASME code specifies the design, materials, and construction of safety valves. The number of safety valves required and the frequency and procedures for testing safety valves is also specified by the ASME code. Adjustment or repairs to safety valves must be performed by the manufacturer or an authorized representative of the manufacturer. Water fittings and accessories. Water fittings and accessories control the amount, pressure, and temperature of water supplied to and from the boiler. Water in the boiler must be maintained at the normal operating water level, or NOWL. Low water conditions can damage the boiler and could cause a boiler explosion. High water conditions can cause carryover. Carryover occurs when small water droplets are carried in steam lines. Carryover can result in water hammer. Water hammer is a banging condition caused by hydraulic pressure that can damage equipment. Feedwater valves. Feedwater valves control the flow of feedwater from the feedwater pump to the boiler. Feedwater stop valves are globe valves located on the feedwater line. They isolate the boiler from feedwater accessories. The feedwater stop valve is positioned closest to the boiler to stop the flow of water out of the boiler for maintenance or if the check valve malfunctions. The feedwater check valve is located next to the feedwater stop valve and prevents feedwater from flowing from the boiler back to the feedwater pump. The feedwater check valve opens and closes automatically with a swinging disc. The valve is open when water is fed to the boiler. If water flows back from the boiler, the valve closes. Water column. The water column minimizes water turbulence in the gauge glass to provide accurate water level readings. Water columns are located at the NOWL. with the lowest part of the water column positioned at least 3 inches above the heating surface. Water columns for high-pressure boilers consist of the main column and 3 tricocks. High and low water alarms or whistles may be attached to the top and bottom tricocks. The gauge glass is used to visually monitor the water level in the boiler. Isolation valves located at the top and bottom permit the changing of gauge glasses. A blowdown valve at the bottom of the gauge glass is used to remove sludge and sediment. Tubular gauge glasses are used for pressures up to 400 psi. All boilers must have 2 methods of determining boiler water level. The gauge glass serves as the primary method of determining boiler water level. If water cannot be seen in the gauge glass, the tricocks are used as a secondary method of determining boiler water level. The middle tricock is located at the NOWL. If water comes out of the middle tricock, the gauge glass is not functioning properly. If water comes out of the top tricock, there is a high water condition in the boiler. If water comes out of the bottom tricock, water may be safely added to the boiler. If steam comes out of the bottom tricock, water must not be added to the boiler. Secure the fuel immediately. Adding water could cause a boiler explosion. Makeup water. Makeup water replaces boiler water lost from leaks or from the lack of condensate returned to the boiler. Makeup water is fed manually or automatically. Boilers can have both manual and automatic systems. If the boiler has both, the manual always bypasses the automatic system. Boiler operators must know how to supply makeup water quickly to the boiler in the event of a low water condition. Manual systems feed city water with a hand-operated valve. Automatic systems feed city water with a float-controlled valve mounted slightly below the NOWL. If the float drops from a low water level, the valve in the city water line is opened. As the water level rises, the float rises to shut the valve off. Low water fuel cutoff. The low water fuel cutoff shuts off fuel to the burner in the event of a low water condition in the boiler. The low water fuel cutoff is located 2 to 6 inches below the NOWL. Low water fuel cutoffs are available with or without an integral water column. Low water fuel cutoffs must be tested monthly or more often depending on plant procedures and requirements. Low water fuel cutoffs operate using an electric probe or a float sensor. The float senses a drop in water level. Switches in the low water fuel cutoff are wired to the burner control to shut off fuel to the burner when the water level drops in the chamber. Feedwater regulator. Feedwater regulators maintain the NOWL in the boiler by controlling the amount of condensate returns pumped to the boiler from the condensate return tank. The correct water level is maintained with a feedwater regulator, but boiler water level must still be checked periodically by the boiler operator. Feedwater pumps. Feedwater pumps are used with feedwater regulators to pump feedwater to the boiler. Pressure must be sufficient to overcome boiler water pressure to maintain the NOWL in the boiler. For maximum safety, plants having one steam-driven feedwater pump must have a backup feedwater pump driven by electricity. Feedwater pumps may be reciprocating, centrifugal, or turbine. Reciprocating feedwater pumps are steam-driven and use a piston to discharge water to the feedwater line. They are limited in capacity and are used on small boilers. Centrifugal feedwater pumps are electric motor or steam-driven. They are the most common feedwater pump. Centrifugal force moves water to the outside edge of the rotating impeller. The casing directs water from the impeller to the outlet. Discharge pressure is dependent on impeller speed. Turbine feedwater pumps are steam-driven and operate similarly to centrifugal feedwater pumps. Feedwater heater. Feedwater heaters heat water before it enters the boiler drum to remove oxygen and other gases which may cause corrosion. Maintaining the proper feedwater temperature will also reduce the amount of scale-causing salts from settling on the heating surfaces of the boiler drum. Feedwater heaters are either open or closed. Open feedwater heaters allow steam and water to mix as they enter an enclosed steel chamber. They are located above the feedwater pump to produce a positive pressure on the suction side of the pump. Closed feedwater heaters have a large number of tubes inside an enclosed steel vessel. Steam and water do not come in contact, but feedwater goes through the tubes and steam is allowed in the vessel to preheat the feedwater. They are located on the discharge side of the feedwater pump. Bottom blowdown valves. Bottom blowdown valves release water from the boiler to reduce water level, remove sludge and sediment, reduce chemical concentrations, or drain the boiler. Two valves are commonly used, a quick opening and a screw valve. During blowdown, the quick opening valve is opened first. The screw valve is opened next and takes the wear and tear from blowdown. Water is discharged to the blowdown tank. A blowdown tank collects water to protect the sewer from the hot boiler water. After blowdown, the screw valve is closed first and the quick opening valve is closed last. Steam fittings and accessories. Steam fittings and accessories remove air, control steam flow, and maintain the required steam pressure in a boiler. Steam fittings are also used to direct steam to various locations for heating and process. Steam pressure gauges. Steam pressure gauges and vacuum gauges monitor pressure inside the boiler. The range of these gauges should be 1.5 to 2 times the MAWP of the boiler. For example, on a low-pressure boiler, a maximum steam pressure on the pressure gauge reads 30 psi as the MAWP is 15 psi. Steam valves. Steam valves commonly used include a gate valve used for the main steam stop valve and the globe valve. The main steam stop valve cuts the boiler in on line, allowing steam to flow from the boiler, or takes it offline. This is an outside stem and yoke, or OS&Y valve. The position of the stem indicates whether the valve is open or closed. The valve is open with the stem out and closed with the stem in. This provides quick information to the boiler operator. The globe valve controls the flow of steam passing under the valve seat through the valve. This change in direction causes a decrease in steam pressure. A globe valve decreases steam flow and can be used to vary the amount of steam flow. It should never be used as a main steam stop valve. Steam traps and strainers. Steam traps remove condensate from steam in lines from the boiler. Steam traps work automatically and increase boiler plant efficiency. They also prevent water hammer by expelling air and condensate from the steam lines without loss of steam. Steam traps are located after the main steam header throughout the system. Non-return steam traps commonly used include the inverted bucket, the thermostatic, and the float thermostatic. In the inverted bucket steam trap, steam enters the bottom flowing into the inverted bucket. The steam holds the bucket up. As condensate fills the steam trap, the bucket loses buoyancy and sinks to open the discharge valve. The thermostatic steam trap has a bellows filled with a fluid that boils at steam temperature. As the fluid boils, vapors expand the bellows to push the valve closed. When the temperature drops below steam temperature, the bellows contract to open the valve and discharge condensate. A variation of the thermostatic steam trap is the float thermostatic steam trap. A float opens and closes depending on the amount of condensate in the trap bowl. Condensate is drawn out by return vacuum. Steam strainers remove scale or dirt from the steam and are located on the inlet of steam traps. Scale or dirt can clog discharge orifices in the steam trap. Steam strainers must be cleaned regularly. Review. The safety valve is the most important fitting on the boiler. The gauge glass is used to visually monitor the water level in the boiler. Tricocks are used as a secondary device for determining water level in the boiler. Make-up water replaces water lost from leaks or lack of condensate returned to the boiler. The low water fuel cutoff shuts off fuel to the burner in the event of a low water condition. Steam pressure gauges and vacuum gauges are used to indicate the pressure inside the boiler. This videotape depicts boiler operation procedures commonly practiced in industry. Boiler operation procedures vary from plant to plant. For maximum safety, always refer to specific plant procedures and applicable federal, state, and local regulations.